Okay, so you just learned what the law of conservation of mass states. The law of conservation of mass tells us that matter cannot be created or destroyed. Therefore, we have a reaction here, a little example we're going to do. And according to the law of conservation of mass, whatever goes into the reaction, the reactants, so in this one that'll be cornstarch, conditioner, and food coloring, must equal what comes out, or the product. So we're going to do a little example. You can do this at home too. You only need 2 ingredients. You need cornstarch, which you might find in your pantry, and you need conditioner. Whatever brand, you don't need a lot of it, doesn't matter the brand, just conditioner. And then you don't have to have, but it would be fun to have, food coloring. So these 3 things are our reactants. They're what are going into the chemical reaction, and we will see what we get out. So as we do this, we're going to take the mass of each reactant and see if that equals the mass of, if the mass of all the reactants equals the mass of our product, which will be Play-Doh. So the first thing I'm going to do is get 4 tablespoons, 4 tablespoons of cornstarch, and record the mass. So I have 1, 2, 3, 4. Okay, awesome. I got lucky. Our mass does not have a decimal right now. So, I was really lucky. Our mass of cornstarch is 33 grams. And I'm gonna go ahead and drop my plus signs so that this looks like an equation I can solve. And remember, I'm going to change my yields, or my arrow, to an equal sign. All right. The next ingredient is going to be conditioner. Hold on. Technical difficulties. And I'm using a digital scale to take the mass of each item. Okay, back in action. All right, so I'm gonna need 2 tablespoons of conditioner. About 2 tablespoons of conditioner. Kind of hard to be exact with conditioner. Whew, this conditioner smells sweet. Smells like coconut. So remember, whatever scent of conditioner you use, you're gonna have that scent of Play-Doh. So I hope you like it. All right, 2 tablespoons of conditioner. All right, so our mass of conditioner is 30.4 grams. And now let's add food coloring. So for food coloring, you can just add however much you want. My favorite color is orange, so I'm going to try to add a little bit of red and a lot of bit of yellow so that I can get orange. We'll see. So I'm gonna add a couple drops of red and a couple more drops of yellow. See if I can get us some orange Play-Doh here. And oh, I'm getting lucky for this video. So I added all my food coloring, and our food coloring was exactly 1 gram. So before I mix these all up, let's pause for a second. If we know the mass of our reactants, we should be able to determine what the mass of our product should be. So we have 3 reactants. The mass of our product must equal the mass of all of our reactants combined. So 33 plus 30.4, you can use a calculator, you can do this in your head, that would give us 63.4, plus 1 should give us 64.4. Is there room for error? Yes, of course, because watch when I mix all of these. What if some stays in one of the beaker? You know, what if it doesn't like 100% come out of the beaker? There is room for error, but it should be very, very close, if not exactly right. I'm gonna try to get all of it for us so we can have it exactly right. Okay. And I'm gonna stir this up. So I mix my conditioner and my cornstarch. And I'm stirring. I should have had a stronger spoon. And I'm gonna add my food coloring so that we can get some color in our Play-Doh. White Play-Doh is cool, but coloring Play-Doh is cooler. And let's see if I got orange. It looks orange. All right, look at my, I don't want to touch it, but look at my pretty orange, a little bit runny. Look at my Play-Doh, it is such a pretty orange. Oh, I love it. Awesome. That is a good orange. So another way you could do this at home, because you probably don't have a beaker, is you could just mix everything in a plastic bag. That's what we'll be doing at school. That's probably the cleanest way to do it, is to put each item in the plastic bag and then just kind of mix it with your hands. So let's go ahead and take our mass. Remember, it should be about 64.4 grams. If I can get all this off the spoon. Oh, wow. Oh, wow. Awesome. So you can see there's still a little on my finger. So we're only 0.1 grams off. When I measured, I got, I'm just gonna put up here, I got 64.3 grams, which is 0.1 gram off, but it makes sense because there's a little on my finger and a little on the spoon. So we know that really the mass of our product is 64.4 grams. So this side has to equal this side. If we, like say this number was missing, could we still solve this? Yeah, of course we could. Pretend we didn't know this is 1. We could add 33 plus 30.4 to get 63.4. And on this side, we have 64.4. So what would go here to give us 64? Well, let me make sure y'all get what I'm saying. So we could add these two to get 63.4 plus, I'm gonna put a question mark, equals 64.4. If we were missing a reactant, how could we solve that? Think about math class. You would subtract this from both sides. Cancel these out. And you would get that your question mark equals 1. So because we know this side has to equal this side, the mass of your reactants has to equal the mass of your products, you can solve for any missing mass, whether it's a reactant or a product. That's what the law of conservation of mass